So when we talk about questions that are based on recasting or transformation of solids, the basic idea is that unless otherwise stated, the total volume must remain the same. So we have a basic question that a sphere of radius 4.2 centimeters, a solid metallic sphere, is melted and recast into the shape of a solid metallic cylinder of radius 6 centimeters. We have been asked to find the height of the cylinder. So for the sphere, the radius was 4.2 centimeters, and of course that is all we need. The cylinder has a radius of 6 centimeters and a height that we have to find. And so like I said, the basic logic is that when a solid metallic figure is transformed or melted or recast into a new figure, the volumes remain the same. So since volume of sphere is equal to volume of cylinder, this means that the volume of the sphere, which is 4 by 3 pi r cubed, is equal to, I will actually make this a different r to avoid confusion, the volume of the sphere, which is pi r square into h. So now that we've seen the relationship between the volume of the sphere and the cylinder, we plug in our values. So what we will get over here is that 4 by 3 into pi into r cubed. Now to not deal with the decimal, I'll write it as 42 by 10, because of course that is what 4 by 2 is. Now it's 42 by 10 into 42 by 10 into 42 by 10, because it's cubed, equal to here. Also I don't write the value of pi. Here capital R is 6, so 6 into 6 into h, which is what we want to find. And it will become clear to you why I have done this, because if you see, I can cancel pi and pi. I can cancel 6 and 142 with 7, 6 and another 42 with 7. Here I can also cancel 3 and 42 to leave 14, and I can cut 1, 4 and 10 to make it 2 and 5, and the 2 and another 10 to make it 5 again. And so we simply get, on this side we have only h left, which is what we want. So we get that h is equal to, all of these have gone away, I'm left with 14 into 7 into 7 divided by 5 into 5 into 10, or 50 into 5, 25 into 10, however you want to do it, 250. And you will just proceed to calculate this value and get to your answer. I'm going to leave it in this stage because you can calculate it for yourself. So whenever you get a transformation of solids question, it's a simple process. The volume of the initial solid is equal to the volume of the final solid. Let's look at one more different type of question in this, but a very, very important question. It is very common that they ask this question. So let's look at it. So now we are given a question which you can see on your screen, which is, we are told that there is a canal which is 6 meters wide and 1.5 meters deep. Water flows in this canal at a rate of 10 kilometers per hour. We are asked how much area of land can it irrigate if in half an hour, if 8 centimeters of standing water is required. Now let us understand this question part by part and get to the answer. The basic logic is that the total amount of water that will flow out of the canal in half an hour will be equal to the total volume of water in the irrigated area in that amount of time. So to understand this, you have to visualize that my canal is 6 meters wide and 1.5 meters deep. Now, if you think about it, that means if you imagine that this is your canal. They have basically given you the height and the width, which is nothing but the area of cross section. So you will get other questions in which they'll give you the radius of a pipe. In that same case, the area of the circle of the pipe is the area of cross section. This is nothing but a cuboid. The volume of the cuboid is length into breadth into height. I have breadth, I have height. To find the length, we will use the flow speed of the water. If the water flows at 10 kilometers per hour, this means in half an hour, in 30 minutes, distance will be speed into time, which is 10 into 1 by 2 or 5 kilometers. Now, because the other measurements are in meters, we will convert this to 5,000 meters. Because the idea is that in half an hour, this is how much water will flow in terms of length. So you now have your length. The length is 5,000 meters. Now, this is the total water from the canal. Like I said, it will be equal to the total volume of water from the irrigated area. Now, you have not been told the shape of the area. All you are told is that you need area has 8 centimeters of standing water. Standing water just means the water will be standing like this. In other words, your height of your irrigated area is 8 centimeters. If you have a figure that has a uniform area with a height, the volume will be equal to area into height. So this is the volume coming in the area. It will be equal to the volume from the canal. And therefore, if volume canal is equal to volume area, we get volume of the canal will be length into breadth, which was 6, into height, which is 1.5, is equal to volume of the area, which is area, which is what we want to find, into height. Now the height is 8 centimeters. Again, to keep consistent units, we will write it in terms of meters, which is of course 8 by 100. And therefore, the area is equal to 5,000 into 6 into 3 by 2 for 1.5 into 100 divided by 8, right? And so now we will simply cancel as much as we can. So of course 2 I'll cut with 6 to make it 3. 8, so 4 and 4, this will become 25 upon 2, and 2 and 5,000 will become nothing but 2,500. So my area is 2,500 into 3 into 3 into 25, and of course this is all in meters, so it will be meters square. So for this one, if you look at it carefully, 25 square we know is nothing but 625. So this is 62500 into 9 meters square. And again, the final calculation you can do for yourself, right? So this is how you will deal with questions that involve flow of water. Whatever the medium the water is flowing through, you find its area of cross section, which, like I said, here was the breadth and depth of the canal. In questions with a pipe, it will be the diameter, the radius of the canal, and therefore the circle that is there. For the length, you will look at the speed of the flowing water and how much time the water flows for. For the area or the other volume, either you will be given something like a tank or some container whose volume you can calculate using normal formulas, or specifically for the irrigation question, it is base area multiplied by height. So if you've not been given a figure, then you will simply be asked to find the area. So in this way, you deal with flow questions. Now let's move on to the final part of the chapter where we learn about the new shape, which is the frustum. So like I said, we are now going to look at the frustum. Again, this is very important because there will almost always be a question from frustum in your exam. It might come with options, but it will definitely be there. So let us first understand what is a frustum and then understand its formulas. So of course a frustum is spelled F-R-S-U-T-U-M, and as I mentioned at the very beginning of the chapter, a frustum is basically nothing but a cone that has been cut parallel to the base at any point between the base and the tip of the cone. So it looks like this. This is what our frustum is. So you might have seen shapes like this before. Hats sometimes look like this, in various situations. And so this is our frustum. Now if we analyze our frustum carefully, our frustum has two radii. We have one radii here, which I will call the larger radii, so capital R. We have one radius here, the upper radius, small r. We have a height of the frustum, which we call h, and of course we have a slant height of the frustum, which we will call L. Now we can derive the formulas for things like surface area and volume, but we are not going to do that because it takes a long time and it is not part of your syllabus. So I will just state the formulas to you. Now the formulas are similar to the cone formulas, which makes sense because the cone is what the frustum comes from. So first, the volume of the frustum is 1 by 3 pi h into r square plus small r into capital R. So of course the cone used to be 1 by 3 pi r square h. Here, because we have two different radii and because when you derive the function, this comes out to be our answer. So it's 1 by 3 pi h into the individual squares of the radii, the upper and lower, larger and smaller, and the product of the radii. So r and r. The curved surface area of the frustum is also similar to the curved surface area of a cone, in which this is pi r plus r L. So again, cone used to be pi r L. For frustum it is pi lowercase r, uppercase r, or upper radius, lower radius, addition into L. And L is nothing but, if you notice, if you try to visualize, I can find L using a hypothetical triangle over here, where this will be nothing but the height, this length will be nothing but big R minus small r. So it would be under root h square plus r minus r whole square. So L is equal to under root h square plus r minus r whole square. Simple Pythagoras theorem. Of course, for the total surface area, we would have to add pi small r square plus pi big R square, simply adding the circles. Just like for normal cylinder questions, normal cone questions, we determine what type of surface area we need to find based on the question. If you are interested in the proofs are done using similarity, and basically you imagine that the cone is complete and using similar triangles find these values. But we're not going to be doing that. So frustum is nothing but a cut cone horizontal to the base. We have the volume of frustum is 1 by 3 pi h r square plus capital R square plus the product of the two radii. Curved surface area it is pi r1 plus r2 or r plus rl, and the L is itself nothing but h square plus big radius minus small radius whole square. So let us understand how to apply this to questions and solve a couple of frustum based questions to get comfortable with the formula. We are given that a metallic bucket is in the shape of a frustum. Now it will not give you what side is bigger in the question, but logically, and we have all seen buckets in our life, a bucket will obviously be in the form of an inverted frustum, which doesn't matter. Our formula will remain the same. So it's a metal bucket. Obviously, again, if it's a bucket, the upper part will be open. So we are told that the dimensions of the bucket are that the radius of the upper sort of circular face, the upper face, is 7 centimeters. The radius of the other end is 3 centimeters and the height is 5 centimeters. We have been asked to find the volume of water that the bucket can hold and the total surface area of metal required to make the bucket. So volume and total surface area. So let's jump into it. We know that the volume is 1 by 3 pi h r square plus r square plus r into r. This is equal to nothing but 1 by 3 into pi, which here I will take 22 by 7, into h, which is 5 centimeters. And so, I mean, of course, we don't need the centimeters here. 3 square plus 7 square plus 3 into 7. And so we get that this is equal to 1 by 3 into 22 by 7 into 5 into 9 plus 49 plus 21. This is nothing but 79. So we are left with 22 into 5 into 79 divided by 3 into 7. And you will proceed to calculate. Obviously, it will be in centimeter cubed. Now, this was to find the volume. In their question, they've asked us to find the total area of metal required. That will be the total surface area. In this situation, the total surface area will be the curved surface area, obviously the curved part of the bucket, plus the area of bottom circle, because only the bottom has a metallic surface. It is open from the top. So obviously that would be equal to pi into r plus r L plus, and in this case pi small r square, because here the lower side is the smaller one and the upper side is the bigger one. And so first we have to find this L. We know that L is under root h square plus r minus r whole square, which is nothing but under root h was 5 square plus r minus r whole square, which would be 7 minus 4, 3. So 7 minus 3, so 4 whole square. So 7 minus 3, so 4 square. So we get it is under root 25 plus 16, 41, which we'll leave it as this for now. And so we get that our total surface area is equal to 22 by 7 into r plus r, which we know is nothing but 7 plus 3, into L, which is root 41, plus pi r square, r being the smaller of the two, so that's nothing but 3 into 3 or 3 square. And so we end up getting, if we want, we can actually leave pi as a constant first. So we have pi into 10 root 41 plus pi into 9, and so our answer is, it is pi into 10 root 41 plus 9 centimeters squared. And so this is how you will deal with a question that involves frustum. Simply find your appropriate information, find your appropriate values and plug them in and solve. Let's look at one slightly more complicated frustum question and then close out the chapter. Now we are going to look at a question that involves obviously a frustum. It involves transformation of solids and a topic of frustums which we are going to cover in the question only. The question, as you can see, tells us that we have a cone of height 20 centimeters. So it's a cone of height 20 centimeters with vertical angle 60 degrees. Now vertical angle means this angle. This entire upper angle is known as your vertical angle. We are told that this cone is cut at middle of its height to form a frustum. So in other words, we cut the cone like this along the middle of the height, meaning that this is nothing but 10 centimeters. We are told, and this is a solid metallic cone, we are told that this metallic frustum, the solid metallic frustum, is then drawn into a wire of diameter 1 by 16 centimeters. So it is drawn into a wire of diameter 1 upon 16 centimeters. Now what this means is, if you think about it, a wire is basically a cylinder. So in the question it asks us to find the length of the wire. So basically it's nothing but solid metallic frustum converted into solid metallic cylinder of this diameter, whose length we want to find. The length will be the corresponding height of the cylinder. But we still don't have all of our information about our frustum. We need to find, if I want to find the volume of the frustum, then I need to find the two radii. We will do that using trigonometry. Now this here, and this is a property that you can use directly, your cone is a right circular cone. This height at the center, if I imagine that I've drawn the height and the height will be perpendicular to the ground, bisects this angle. Therefore, this angle is nothing but 30 degrees. And so if I mark my figure A, and I sort of do this here, B, C and then D, E, we get in triangle ABC, I want to get BC. I know the length AB. This is from the respect of the 30-degree angle. This is the perpendicular and this is the base. So I will get tan angle A is BC upon AB. Like I said, angle A is half of the total angle, which is tan 30 is equal to BC, which is what I want to find, upon AB, which is nothing but the height of the cone, which is 20 centimeters. Of course, tan 30 degrees is 1 by root 3. So we get that BC is equal to 20 by root 3 centimeters. Do not convert. Leave it like this for now. Next. Similarly, in triangle ADE over here, so similarly, in triangle ADE, tan 30 is equal to DE upon AD. AD is what I know, DE, because we cut the cone at halfway point. So if DB is 10, AD is also 10. So we'll get that DE is equal to AD tan 30 or 10 by root 3 centimeters. And so we get all of our information of our frustum. The height of the frustum, it was cut at half, is nothing but 10 centimeters. The lower radius or the larger radius is 20 by root 3. And the upper radius, the smaller of the two, is 10 by root 3. And now we will do volume of frustum is equal to volume of wire, which is itself nothing but a cylinder. So we know volume of frustum is 1 by 3 pi h r square, capital R square, RR equal to volume of wire. As we said, it is nothing but a cylinder. So it will be pi into the radius of the cylinder square, which here I've been given a diameter, so I'm going to write it as diameter by 2 whole square, because remember we were given the diameter of the cylinder. So it's a capital D that we've used there, so we'll use it here as well. So D by 2 into the length of the wire, because length and height for a wire is the same thing. So first of all, we notice that I can cut pi and pi. Now let's put in all of the values that we know. This is going to be 1 by 3 into h, which is 10, into, in the brackets, now lowercase r was 10 by root 3. You will now see why I told you not to multiply. This will be 10 by root 3 square plus 20 by root 3 square, which is capital R square, plus r into r, which is 10 by root 3 into 20 by root 3. And this is equal to, of course, the pi has already been cut. The diameter is 1 by 16. So the radius will be 1 by 16 by 2, which is 1 by 32. And so we'll get 1 by 32 into 1 by 32 into L. And so therefore we can see that L will simply be equal to, we cross multiply the 32s to the other side and we leave our, and then we'll solve. So this will be 1 by 3 into 10. Now in the bracket, 10 by root 3 square is 100 by 3. 20 by root 3 square is 400 by 3. 10 into 20 upon root 3 into root 3 will be 200 by 3. And of course, like I said, into 32 into 32, because we cross multiplied the 32s. And so we see that this gives us 1 by 3 into 10 into, this will become 700 upon 3 into 32 into 32. Of course, once again, you can simplify and calculate. So this will be 7,000 into 32 squared divided by 9. And of course, the unit will be centimeters because we have used centimeters throughout the chapter. And so once again, you can find the final answer for yourself. Nothing overly major. I just don't want to messy the page, right? And so this is how you will approach questions. So the most important thing that we learned in this question is the concept of the vertical angle of the frustum. So this is what you will keep in mind. When they give you the vertical angle, it is this angle of the upper part of the cone. If they say semi-vertical angle, they mean the half angle of the triangle that you use. If you take the triangle with the altitude, it forms a right angle triangle. Obviously, that's the point of altitude, with this angle being half of the total vertical angle. We use normal applications of trigonometry, heights and distances, basic trigo, to find our appropriate values, solve, and then of course this was a solid transformation question. So volume of initial solid equal to volume of final solid. So the main thing about this chapter is, as long as you keep your formulas clear and you are sure and aware of what you are supposed to be doing, you will have no problems. So with that, we conclude surface areas and volumes, and we can move on to the next chapter.